Let's practice graphing a sine function that has translations together. Now, if we're going to be graphing a sine function that has some translations together, make sure you already feel comfortable with how to graph the parent function of the sine function. Before we get started, if you'd like to do this problem with me with the same exact worksheet, you can find a link to the PDF below, and you can go ahead and print that out as well as look at the annotated answer key as well. Alright, let's get started. Our function here is f of x is equal to sine of the quantity of x plus pi over 4 minus 3. Now hopefully we know that our sine function is going to take this form where we're going to have a value for a, b, c, and d, and they're going to have different effects on this sine function. And while a and b were equal to 1 and c and d were equal to 0 for the parent function, it's going to change a little bit for this particular one that we have here. So labeling this function a little bit more clearly with those values of a, b, c, and d, we have f of x is equal to 1 in front. That's going to be the value of a. That's going to be 1 times. And then we're going to have, we're going to have sine of the quantity of, do we have a value for b? Looks like b is going to be 1 here. And that's going to be multiplied by x. And then we have this plus pi over 4. So that's really going to say it's going to be minus. And what we're going to write here is going to be a negative pi over 4, right? So our formula has a minus sign in here, so this c value must be negative, okay? And then after that, what we're going to do is we're going to go ahead and add a d value here, and d is going to be a negative 3. So we can say we can add a negative 3. Now a couple key parts that could be a little bit tricky is that our formula has a minus c value. So because we have this plus pi over 4, then we have to subtract a negative pi over 4, and that's where the positive pi over 4 comes from for this particular function. And then our d value here, because we have this plus d at the end in our formula, then we're going to go ahead and add a negative 3 so we know the value of d. So let's go ahead and write these in. We know the value of a is going to be 1, the value of b is going to be 1 as well. C's value is going to be this negative pi over 4, and d is going to be negative 3. Writing these in, we have a 1 for a 1 for b, a negative pi over 4 for c, and then a negative 3 for d. As to whether there is a vertical reflection or not, for this particular function, we can see that a's value is positive, so that means we're not going to have any reflections here. If a was negative, then this would flip across the x-axis. Similarly, for the horizontal reflection, we're not going to have one just because b is also a positive value. So we're going to say none. If b was negative, we would have a reflection across the y-axis. Our amplitude is dependent on the value for a, and so that is going to be the absolute value of a. So if we go ahead and take the absolute value of 1, that's just going to equal 1. So we know our amplitude here is 1. That's not going to change. As for the period, keep in mind that we have a formula to find the period. The period for the parent function is always just going to be 2 pi or 2 pi divided by b, but again, b is equal to 1 in the parent function, but in this case, it's going to be the same. Since b is equal to 1 for this particular function, we're going to notice here that this is going to have the same period as the parent function because 2 pi divided by 1 is still just going to equal 2 pi. Again, if you're on a number line or on a graph and you're trying to approximate this, keep in mind that this is going to be approximately 6.28. So if you're a little confused looking at an x-axis, you can look for that as well. Now for the midline, that is typically going to be at y equals 0, but notice here that we're going to have this d value of negative 3, and that's going to shift it down. So that d value lets us know where the new midline is going to be, and that's going to be at y equals negative 3. So we have a vertical shift of down 3 units. Now what about the minimum y value for this graph as well as the maximum y value for this graph? Try to recall that the minimum y value is going to be the midline minus the amplitude, so that's going to be this negative 3 value over here, take away 1, negative 3 minus 1, and that is going to be at negative 4. Let's go ahead and put that over here. And for our maximum y value, that's going to be the midline plus the amplitude, so midline is negative 3 plus 1, that's going to be negative 2, so that's going to be our maximum y value. It's going to be at negative 2. Let's move down just a bit here just to get a little bit more space. Before we get into the specifics for this particular graph, let's try to remember what happens in the parent function. This table over here are going to reserve for the parent function, so you can see how the parent function is then related or translates to the function we have in this video. But let's go ahead and see, what does the original or the parent function for the sine wave actually do? Well, keep in mind that it starts at the origin, it comes up, it goes back to the x-axis, it goes down, and it comes back up to the x-axis. So that's going to be what the parent function typically looks like. If you forgot what the actual points were, hopefully this helps refresh your memory. It always going to start at 0, and then it's going to go to pi over 2, which is 90 degrees, and then we're going to go over to pi, which is 180 degrees. Then we go over to 3 pi over 2, which is 270 degrees, and then we go back to 2 pi, which is at the same location as where 0 was. On that same idea, let's try to remember that it starts at 0, 0, that's this point right over here, and then it goes up to a y value of 1, that's going to be up here. Then we go back down to a y value of 0, that's on the x-axis again. Then we go down to a y value of -1, which is right here, and we go back to a y value of 0. So these are the 5 important points for the parent function. So how does that parent function actually help us with this particular function in this video? Well, we see here that typically our x values for the parent function are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi, but we had a horizontal shift, right? And we had a horizontal shift that went over pi over 4 units. Again, that value is being told to us by the c value that we haven't really talked about yet, but this is telling us that we have a shift horizontally of negative pi over 4 units. So taking this into consideration, let's go ahead and take the 0 here and shift pi over 4 units to the left. So 0 take away pi over 4, that's going to end up being negative pi over 4. So that's a shift of pi over 4 units to the left. Then we have this pi over 2, which is really going to be 2 pi over 4. If we have half a pi and we take away a quarter of a pi, that's going to leave us at a 1/4 of a pi. So that's going to be pi over 4. Then we have this full pi, or 1 entire pi. If we lose a quarter of it, or move a quarter to the left, that's going to leave us with 3 pi over 4, or 3/4 of a pi. Then when we had originally 3 pi over 2, or really 6/4, if we move 1/4 to the left, that's going to leave us at 5 pi over 4. And then finally, if we have 2 full pi's, but we move to the left 1/4 or lose 1/4 of it, that's going to be 1 3/4, or we could say that's going to be 7 pi over 4. So again, this plus pi over 4 lets us know that we have a c value of negative pi over 4. So each of these x values are going to be moving pi over 4 smaller or to the left. So each of these are taking away 1/4 of a pi, and that's how you get your new x values that we're going to be using for this particular problem. Using this information, if you want to know where this graph is going to be starting, we know it's going to be at negative pi over 4, so we're going to go ahead and write negative pi over 4 over there. Then where is this thing going to be ending? Well, we know it's going to be at 7 pi over 4, so let's go ahead and write that in for where this graph ends for one whole period. For the halfway point, that's going to be at 3 pi over 4, so let's go ahead and write that in. The 1/4 of the way through point is going to be at x equals pi over 4. Go ahead and write pi over 4 here. And then let's go ahead and say our 3/4 point, that's going to be this 5 pi over 4. Oh, and I forgot that I didn't actually write in the period, but we said earlier it was 2 pi. Again, the b value is 1, so that has no effect. So we know that the full period is here. It's still going to be 2 pi. So if you see what is the distance between negative 1/4 pi and 7/4 pi, that is going to be 2 pi difference from the beginning to the end. Everything just got shifted pi over 4 units to the left. Now, how do we get these y values or these f of x values? Should we just use these ones over here? Well, remember, these are y values. They're telling us how high these points are going to be or how low. And we actually got to remember that we have a shift, right? This d value of negative 3, this minus 3 told us that all of the y values were going to be shifting down 3 units. So what we're going to do is take this 0 here, and let's take away 3. If we take 0 and take away 3, that's going to leave us with a negative 3. And if we go ahead and take this 1 over here and take away 3, that's going to leave us at negative 2. If we take the 0, take away 3, that brings us down to negative 3. If we have this negative 1 and we take away 3, that's going to leave us at negative 4. And finally, if we have this 0 and we take away 3, that's going to be at negative 3. So basically, the c value of negative pi over 4 translated all of our x coordinates from the parent function to the left pi over 4 units. And this d value of negative 3 shifted all of our y coordinates down 3 units. Now, if you wanted to, you could take each of these x values like this x equals negative pi over 4 and substitute it back into the original function here. You can either plug it into a calculator and do it in radians or degrees, or you could do it by hand using a unit circle, and you're going to get out that the y value is going to be negative 3. And then if you want to just double check this and practice your trig, you can take all of these x values as well and substitute them in for this x in the original function. You can do that either by hand with a unit circle or using your trig ratios, or you can use a calculator as well, and you should get the same y values that we got in the table below. All right, let's start graphing here. Putting this on a graph, feel free to scale this how you would like to. I'm going to go ahead and say that each of these tick marks are worth pi over 4 units. So between each of these, this would be 0. This would be, I guess, 2 pi over 4, or just pi over 2 if we just simplify that down. And then in between 3 pi over 4 and 5 pi over 4, that would be 4 pi over 4, which is just 1 whole pi. And in between 5 and 7 pi over 4, that should be 6 pi over 4, but that simplifies down into 3 pi over 2. Now that we have each of our x values down, let's take a look at our y values. Looks like all of them are going to be negative here, so let's go ahead and label down here. We have negative 1, negative 2, negative 3, and negative 4. For our first point, we have negative pi over 4 comma negative 3. Let's go ahead and plot that down. It's going to be over here on the bottom left. For our next point, we have pi over 2 comma negative 2, so that's going to be pi over 2 and then negative 2. That's going to be right down here. Next, we're going to go ahead and plot 3/4 pi and negative 3. So 3/4 pi and negative 3, that's going to be coming back down right over here. Then we have 5 pi over 4 comma negative 4. That's going to be all the way down here, right on the edge of my graph. And then we have 7 pi over 4 comma negative 3, and that's going to come up a little bit here. Sketching this out, looks like we're going to be coming up, and then we're going to come down. And then we're going to come back up. This right here would just be one full period for this sine function. Of course, this is just one of the periods, so if we're going to go ahead and continue this pattern, this is what it's going to look like to the right. And then if we go ahead and plot some more points to the left here, this is what it would look like to the left. Going ahead and labeling a couple other things to hopefully make things a little bit more clear. For a midline, keep in mind our midline was supposed to be at y equals negative 3. So if I go ahead and show that, this is where that would be. This would be that midline where you can see the graph goes above and below the same distance from this midline. And then if you go back and think about what our minimum y value was and our maximum y value was, that was going to be the minimum at negative 2 and the maximum at negative 2. So we go ahead and take a look at that. Here you can see the highest y value we have is going to be up here at y equals negative 2, that horizontal line. And the lowest y value here, which helps dictate our range, is going to be our y min, and that's going to be at y equals negative 4. So you can see a couple of locations where that minimum does occur, right over here, and then we have our maximum, which occurs here and over here. Finally, keep in mind that our amplitude was 1, so going from that midline, you can see that we do go 1 above that midline and 1 below that midline, so that lets us know that our amplitude makes sense here as well. So there you have an example of graphing a sine function that has some translations. So again, in this particular sine function, we did have just basically a horizontal translation of pi over 4 units and then a vertical translation of 3 units. So we just shifted it left and right and up and down. And when that's the case, it's really helpful to know just what the original 5 points are for the parent function. And then you can just go ahead and move the x values left or right depending on the value of c, and then move these y values up and down depending on the value for d. So hopefully you found this video helpful. If you did, feel free to share this with a friend or classmate that might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.